In the last video, we talked about how to find the direction that a parabola opens, and we also talked about the vertex, finding the vertex. These are the four different versions of the equation you're going to use when you're talking about an equation for a parabola in focal form or focus form. These are kind of the different variations. You got your x squared versions with your positive here and negative here, that's up and that's down. And then you have your y squared versions. In this video, what I want to show you is I want to break down how to find focal width and how to find the distance between the vertex and the focus. That distance between vertex and focus we talked about is p. We use the letter p to represent that. And then the focal width is like the width of your parabola at the focus, and that's 4p. So if you notice in all of these different equation forms, they have this 4p piece. Sometimes it's a positive number, sometimes it's a negative number, but there's that 4p piece there. So when we're talking about focal width, what we're really looking for is 4p. We're looking for like this number right here, and because we're talking about a width, which is like a distance, we're going to kind of disregard the negative. We don't really need that piece. So focal width is actually really easy to grab. It's part of your equation. You can see it in the equation like pretty much automatically. Just like you can see that like the vertex here is going to be 3, -5. The focal width is 16. So if you want to do that, then focal width is just going to be 16 here. Okay. Now the distance from the vertex to the focus is 1/4 of that in every parabola. It's always just p. So in order to find out what p is, all we got to do is divide this number by 4. So p is just 16 divided by 4, which is just 4 in this case. Just as a quick kind of reminder here, when we have a parabola, I'll draw you a little picture here. We have the vertex, the focus, and the directrix. This distance right here, from vertex to focus, we call p. And that's the same as this distance from vertex down to the directrix. That's also p, that distance there. And then the focal width is the width of the parabola. If you draw like a line through the focus, it's the width of the parabola through that line. And this is always going to be 4p. That's your focal width. Okay? And again, you see that basically right out in front of the parentheses usually. Okay, so in this case, focal width is going to be 32. Okay, p is going to be 32 divided by 4. So the distance between the vertex and the focus in this case would be 8. So 32 divided by 4. If you want to, you don't have to do it this way. Oh, there's the bell. If you want to, you can set up an equation. You could just say, when you get your focal width, you could just say 4p equals 32, which is where that's coming from. And then you just divide both sides by 4, so p equals 8. Right? You don't have to do that. You're pretty much going to be dividing by 4 every time. So whether you want to just remember divide by 4 or set up that part of the equation, just say, well, hey, this 4p part is 32. And remember that we're kind of disregarding the negative here because we don't want negative distances. Okay, in this guy right here, the focal width is just 8. So focal width is 8, and then p, the distance from vertex to focus, is 1/4 of that, or it's 8 divided by 4, which is going to be 2. Okay. This one, you don't really see a number out here, but just like normal, when we don't see a number multiplying something, we don't see a coefficient, we assume that there's going to be a 1 there. So this is like a -1 times x plus 4. So the focal width for this guy is going to be 1. If we want the p value, the distance from vertex to focus, which is also the distance from vertex to directrix as well, it's the same. We divide this by 4. So if we take 1 divided by 4, then the p is 1/4. And that's okay. You can get a fraction there. You don't have to get a whole number. Most of the ones that I picked for your assignment, they end up coming out nicely, but you could potentially get a fraction there, and that's okay too. So this is how to find focal width and p, which again is the distance from vertex to focus or from vertex to directrix. It's the same. And it's 1/4 of the focal width. So that's how you do that. In the next video, we're going to put a lot of these pieces together, and we're going to take all these features and learn how to graph a parabola when it's given to you in this form.